Of course, there's a standard form of a circle. You already knew this. Today we are also going to center our circles at the origin. It is. There's no H, there's no K. You guys already know the H and K formula for this because you did that last year in geometry in section 10.7. X minus H quantity squared plus Y minus K quantity squared equals R squared. You did that, I know. All right, you did that. We will go back to that in section 10.6 in Algebra 2. But for right now, we're just revisiting how do you write equations of circles. Everything's going to be centered at the origin, so there's no shift here. Real simple equation again, x squared plus y squared is r squared. Boy, that looks familiar. Well, we did that with trig too, didn't we?
No,
yes.
Different letters.
Yeah, it was the same idea.
Wait,
So, what's that?
What trig was?
Remember when we did standard position? Find all the, given the ordered pair, what's the 6 trig functions for an internal side of a certain ordered pair? You dealt with the x, y, you found your r, and you did your x over r, that's what it was. So again, in this case here, this is not going to be scary bad. X squared plus y squared is r squared. So when we get to it, to graphing a circle equation, I am not even going to bother with graph paper here. If I'm going to graph this, this is going to be really difficult for a lot of you, so stay with me. I have y squared equals 25 minus x squared. It's a circle. What do I have to have on one side?
X and Y.
I got to have the x and the y on the same side to make this work. So I'm going to have y squared plus x squared equals 25. Is it okay that the x and the y have switched spots?
No.
Yes, it is.
How does this addition?
Now, guys, enough with the handsies. At this point here, could we all figure out what our radius is?
No.
What is it? 5. The radius is 5. Now, the center of this circle is at the origin. If my radius is 5, in order to graph this, what do I do? You're basically plotting the quadrangles with a radius of 5.
What if we have trouble drawing curved lines? If you're below average.
Can I draw a square?
I'm below average when it comes to drawing circles. It's quite okay. We'll all get over it.
I drew
I say that's pretty average.
It's horrible. It looks like a deformed potato. All right. Hey, I'm pretty close on marking off my 5s, though. That's pretty good. I'm pretty consistent. Okay.
No, you cheated.
Yeah, but I'm looking at the tick marks. See how close I am for marking out 5s on going all the way around?
Pretty good. On the upper left, the second quadrant is actually really good.
Every once in a while, I'm all right.
1 out of 4.
I'm not going to bother with this. Let's write the equation of a circle. Again, our center of our circle is going to be placed at the origin in this section, which means your lives are very, very, very easy. So, excuse me. So if the point 1,4 is on the circle, the center of the circle is at the origin, I need to figure out what?
What r squared is it?
Right. So what we do here is visualize what you're doing. Here's your origin. And there's the point on the circle. I need to figure out what the radius is. What?
X squared plus y squared.
Because where is it located at? Since it's located at the origin, the formula is just x squared plus y squared is r squared. There is no shift involved. Isn't this also the Pythagorean theorem
No.
for x and y and r? What's r squared?
3 squared. I mean 9. R squared is 9. R squared is 9. Oh. It's the hypotenuse.
What's 1 squared?
Oh, 1. I thought you said r squared.
I did. What's 4 squared?
8. 4 squared, 16. Oh.
So what's r squared? 17 is r squared. Now, you're right, the radius is the square root of 17, but does the formula for writing an equation of a circle have just r, or does it have r squared? It's r squared. So my answer would be x squared plus y squared is 17. And that's it. But you kept it with such conviction that you were right. I'll give you credit for that, but
Why did I?
What notes they're rolling to say
okay. All right, let's see if I can make this difficult, because I really don't think I can. Let's find the equation of a line that is tangent to a circle.
That's not funny.
Do you guys remember what it meant to be tangent to a circle from back in chapter 10 in geometry? Touches at one point, and what is it to the radius? Perpendicular. So a tangent line to a circle touches the radius at one spot, and it's perpendicular. I don't know if you vaguely remember that. So what I want to do here is write the equation of that line that is tangent to the circle that is going through the point 2, 3. So I know that the origin is, I'm starting at the origin. This point is at 2, 3. What's this? What's the slope of the radius? What's the slope of the radius? What is it? 3 over 2. Everybody agree? Changing y or changing x. In this case, since my secondary set of points is 0, 0, all I have to do to get my slope is y over x. So my slope here is 3 over 2. What's the perpendicular slope to 3 over 2? Do I also have the set of ordered pairs that slope has to go through? What is it? 2, 3. So you go back to the writing the equation of the line given a point and a slope. Point slope form. Yeah. Point slope form, as you guys remember, is one of the easiest things to use. Those of you guys who are going to take the ACT next week, you're probably going to run across that once or twice. It is such a common thing to use. It's very easy. This problem, I believe, I think it was even in the practice. It was on one of the practice tests, if I'm not mistaken. I know it was in the book. I've seen this problem in the book before, the ACT prep stuff. Again, it's nothing more than just substitution. Y minus 3 is negative 2/3. X minus 2. Distribute out, watch your fractions when you're moving stuff around. Y minus 3 is negative 2/3, x plus 4/3. Now when I add that 3 over, I'm going to write it as 9 over 3. Is that okay? So what's 4 over 3 plus 9 over 3? 13 over 3. I'm just keeping in terms of the fractions. Your calculators will do that as well if you use the fraction bar. And just leave them in fraction form. Hopefully. It is. It does. This stuff doesn't really get fancy until we get to the shift stuff. But you guys did the shift stuff on circles last year, so it's this section should not be very difficult. That's all. That's it. You probably did that with Seb. I bet you did that with Seb last year.
Didn't have
Oh. Well, if you had Seb, you probably did that. Maybe. I think I've got one more like that. Yes, sir.
Why is the slope 3 over 2?
The original slopes? When you're reading slopes, you're always moving from right to left, so it's going up and right.
Oh, the radius.
Yeah. Correct. This slope is the negative because it's the slope of the tangent line. Okay. The original slope, when you're dealing with these problems because you're centered at the origin, Your original slope will always be y over x. It just happens that way. You don't have to even do any work. So you just remember the original slope for these types, because you're centered at the origin, it's y over x. Perpendicular slope is just flip it and change the sign and go from there. So take a quick second. Let's do this one, and I'll give you some homework. Like I said, this is a very simple section. Should not take you very long to go through. That'll give us time tomorrow to start ellipses, and that's where things get to be more interesting. I should have done ellipses today. This is tomorrow. I totally forgot about that. Ellipses. No.
So we're gonna need to look that up on your website.
Oh yeah. They're not tough. They're very easy to work with because everything's centered at the origin. There's gonna be a couple of new terms in there.
Easier than this.
It's a little bit more complicated than this, but it's not great. It really isn't. Okay. Slope. Your original slope is 1 over 2. Perpendicular slope is -2. From there, you just go y minus 1 equals -2 times x minus 2. Y equals -2x plus 4 plus 1. Yeah, plus 5. All right. What? We're okay?
Yeah.
Okay. Yeah, the look going.
I next to the slope.
What? Point slope form. Point slope form is the best friend in the whole wide world, except for Lena. She's got this big You can't say something bad about point slope form. Point slope form is awesome. It's always there for you. Because there's a point to it. All right, here we go. On number 1, most people forgot when you had to factor out the pi within the parentheses. You had to figure.